Okay, hello. I want to talk to you about forces right now, and so I'm going to make a list of some of the forces that we're going to see in this class and explain what they mean. Some of the basic forces include, for example, an applied force. An applied force is just pushing or pulling. Forces in general mean pushing or pulling, but if someone is actually pushing on an object, that's what I would call an applied force. You're not likely to necessarily see the term applied force, but you will see the term a force is applied, for example, if that makes any sense. There's other forces that you will see. Tension you might see, and that is a force that is through ropes or cables. So if I pull on something with a string, for example, that would be called a tension force. There is a gravitational force. That is also known as your weight, for example. So gravitational force is the force between any two objects that have mass, right? So really any two objects, my left hand and right hand, have a gravitational force attracting them. It's very, very small, and in fact gravitational forces tend to be pretty small. If you're talking about the gravitational force between an object and the earth, that's specifically your weight. You can actually find gravitational forces between other kinds of objects as well. You will see friction. And friction is a force that resists movement. Keep in mind, all forces use the same units. They're all pretty similar in many different ways. An object is moving to the right. Friction resists that, so it's actually going to push on it to the left to kind of try to slow it down. It doesn't always succeed in slowing it down, but it can. What are some other forces? You'll see a normal force. And this is probably the most confusing force of all. It's applied by flat surfaces. So anytime an object is touching a flat surface, there is a normal force. For example, if I push on this wall, the normal force of the wall is pushing back on me. So the wall actually pushes on me. This comes out of Newton's third law. A book sits on a table while the table pushes up on the book. That would be a normal force. If an object is thrown or dropped and it's flying through the air, there is no normal force. It needs to be against a flat surface of some kind. Air resistance is a force. And air resistance is a lot like friction, except it tends to be caused by air. So it's like friction, it's a resisting force. The only main difference is that you can actually have friction if an object is not moving. If you're pushing on an object but it's not moving, there's friction. But for an object that's not moving, there's never going to be any air resistance. There are electrostatic forces. Electric forces, or we can say electrostatic, either way will work. And that's between charged objects. You can have magnetic forces, and that's between magnets, or objects that have become magnetized. For example, a magnet on a paperclip. The paperclip is actually magnetized when it's put near the magnet, so that is a magnetic force. There's forces like lift, which helps keep airplanes up, buoyancy, which keeps objects floating, and anytime you're in any kind of fluid, including the air, for example, there is a buoyancy force. You'll see, we're not going to talk too much about lift and buoyancy. You'll see a strong force and a weak force also mentioned. And the strong force relates to, well, basically keeps protons and neutrons together. You'll see the weak force is responsible for radioactive decay. And I'm sure that there are other ones that I'm forgetting as well. There's lots of different forces, and many of them actually can be simplified down into things. Applied force, for example, is really just a result of electrostatic force between electrons in different objects. Like I pound on this, I can't go through it because the electrons in the surface of this will repel electrons in my hand. Lots of forces. We're going to learn more about this as we go on. Thank you for watching.